Thank you so much. So welcome everybody. Thank you so much, GDG Brunei, for having me here. This will be a talk about MVVM architecture, how to work in Android, how to work with clean architecture and build awesome apps that are scalable in the future. So as the introduction, my name is Gastón Saillén. I'm from Argentina. I have a YouTube Sociedad Android where I upload Android content. And I have founded a food delivery app months ago that I have been working with this architecture in that, and let me just add new features and fix bugs in a more easy way. So before I start, I want to show you guys all this situation in a company. As we can see in this image, we have a boss that is telling us that we need to define an architecture that will let us scale. So there are some choices in the team. One suggests MVP, another one MVVM, and there is a guy right there that he doesn't know what is architecture or even architect what. So the consequences of that is not really good. So for this, it has been adapted like an architecture to work with our apps. And what is the definition of architecture before we start working with it? So as Google definition is a software architecture defines the way of working in a system, such as building new models, but it must also give an insight into the type of application it describes. So basically, we have different models that we need to chain one and another with the other ones. And this chaining will let us scale in a way that we need, we will be, it will be more easy for us to add new features, and it will be easy for us to maintain the current code. So we don't have all this messy 2000 lines class to maintain. Instead of that, we separate this in different models that we'll be talking about in the next slides. So this will be more easy for us to code, and it will be more fun because it will be more maintainable as well. So what are the objectives of an architecture? So there are so many objectives, but I think these are the most important ones. So the framework I mean, an architecture is a framework independent. So there is I mean, no matter where you are working with, Android Studio or Swift or any another language or IDE, is framework independent. So it will be the same. The concept of architecture is the same in all places. It's easy to test because when we modularize this code in different models, we can test each separate model. So it will be more easy for us to describe tests and just build them up to write the unit test for it. Is UI independent? So this is a really nice thing because we don't need to have all our business logic inside one class that also will be handled with the UI. So we separate this in different things that we are later on, we're chaining that. And since that, we have the UI independent of the other models. So it's easy to maintain. So one change in one file will not broke anything in the other files. So it will be easy to find bugs, it will be easy to fix them, and it will be easy to maintain in the future when the code grows. So it's a DB independent, so we can have multiple implementations of different databases. This will be implemented in a layer that we call the repository. Later on, we will be talking about that. But we can have whatever DB out there, and it will be working as the same, just touching that layer. And it's independent of any external component. So each component describes one one thing, and there is no reason to change. So it's independent for the other models on the other components. And I think the most important one of these objectives is the code reusability. So right here, we can see that if we have a clean architecture in our application, it will let us not copy and paste and duplicate code, but instead we can reuse the code that we wrote to use in another models. So it will be easy for us to write less code, be less prone to errors, and build awesome apps. So there is a really nice quote about Robert C. Martin. It's a guy who had so many books about clean architecture. We will be talking about that in the next slides, but it's a really nice reference about all clean code and clean architecture. It's also known as Uncle Bob. And the quote says, so if you want to go fast, if you want to get done quickly, if you want your code to be easy to write, make it easy to read. So what it's telling right here is that if we want to deliver a feature in a really short amount of time, we need to concentrate in writing code that we can read and understand instead of doing things really quickly and don't understand what we are making. So the evil thing about doing the things really quick is that we need to add comments on our code. And when we add comments on our code, we are making it really hard to read because the code is not describing itself. One of the principles of having a really great architecture is not having comments in the code itself. You can have one or two comments, but if you have your entire file class with comments, it's like something that we call a code smell. So it's really important to the code to be describing itself when you are reading it. So it will be really easy to write and maintain. So in Android development, there is something called model view model. And it's a new pattern about architecture that we can build apps on. So let's talk about it and let's see how it's done in Android. So what is MVVM? So MVVM is a new architecture pattern suggested by Google to create our Android applications in a simple way. It uses the observer pattern, and the view model is in charge of communicating our information to our UI. This is done in a layer called the presentation layer, and it's also part of the Android Jetpack libraries. So the Android Jetpack libraries, they are standard libraries for Android development nowadays. So if we want to build any app from now on, we can depend on Android Jetpack, and Android Jetpack has tons of really nice libraries. For example, there are libraries for navigation called navigation components, and in that library, you can manage your navigation inside your application really easily with a graph and doing all these fragment transactions, animations, and so on more easily. So Android Jetpack also offers like Work Manager and another cool APIs to work with, and it's really nice. And also in the architecture part of Android Jetpack, we have MVVM, and we are going to talk about it. So what are the advantages of using MVVM? So there are three that I see the most valuable one are easy implementation. We separate logic from our view, and it's adaptable to the life cycles. So let's talk about each of these. Easy to implement. It's really easy. I mean, there is no magic into it. If we can see the graphic in the right, we can see how we can decompose our current application into a good architecture with MVVM. So first we have our activity or fragment. So the activity or fragment will just handle the UI components inside that model. So there is no way from the activity or fragment to do things about business. I mean, fetching something from the server or doing some conversions or mappings or anything like that. The UI and the activity and fragment will only show UI. It's nothing more than that. Then we have another layer that is called view model. So the view model inside has something that it's called live data. So let's look at the view model like this. The view model is a container where it has live data inside of it. The live data is the component that will hold the data that is coming from the other layer, that this layer is the repository. But the view model will handle all the configuration changes also in the application and all the life cycle aware components. I mean, when you rotate your activity, your phone, sorry, your activity and fragment will be recreated, and the view model will make a pause, will save the live data objects, and when the activity or fragment recompose from that rotation, it will bring the current latest data from the live data to the UI components that are observing to it. So we talked about before about the observer pattern. If we can see right here in the graph, we have an activity that is pointing to the view model. That arrow right there is an observer. So we are observing live data inside the view model from our activity. Each time our view model change that live data, our UI will be triggered with that latest information in that live data. So that is, I mean, that is 90% MVVM or 100% MVVM. So the magic happens in the view model. The other parts of the layer that are below, the repository, remote data source model, and so on, are part of all the current architectures before. I mean, MVP had it, MBI has it also. There are so many architectures that use the same layers below view model, but in this case, what has changed right here is the way that we communicate data from an activity with the view model. So the latest layers, the repository, is in charge of deciding where to bring the data from. So if we want to bring the data from a server, we call the remote data source. Let's say we have a retrofit on it, and then we can call a web service that will fetch some data in any API, or we can call Firebase. Or if we want to make a call locally, we can use Room and use a local persistence like SQLite. When the repository has this data, it will deliver that data to the view model, and then the view model will deliver that data with live data into our activity or fragment components. So what is the difference between MVVM and MVP? Because I was talking about it's so similar about all the architectures. The only thing that is currently changing is the view model or the presentation part. As we can know, the MVP is model view presenter. So what is the major difference between this? The MVVM pattern is an observable pattern, and we don't need to pass any view reference into the view model. So the view model will just handle the data and pass that data to the UI. But instead, in MVP, we need to pass the view reference to the presenter. So when we pass that view reference to the presenter, now the presenter knows about the view and needs to detach that view or set that view to null when the life cycle of the view changes. So the view model so the MVP, the presenter, can't leak any view or have any null reference to the view when the view is not there. So that's are the main difference between these two architectures. And what I recommend right now, since MVVM is really advanced and it's really the way nowadays to go, I would recommend MVVM. But MVP is also a good choice. There are libraries that solve all these null references or lifecycle problems with MVP. But I think that MVVM is cleaner because we don't pass the view into the presenter. Instead, we do a UI logic inside the view model, and then we prepare that data to send it to the UI. So we don't care about the UI in the presentation layer. So I think that we have enough talk about all how it works and like that. So let's see a current example of how to work with clean architecture. So before I get into the code, I want to show the example we are looking. So there is an app that I have made that is called Cocktails app. Basically, we'll list a list of cocktails, and if we can select each cocktail, it will tell us how to prepare this cocktail, and we can save this cocktail into our favorites, and then we can just look into the favorites and look that the cocktail is there. It also provides the repository pattern where the data will be coming from the server, but it will be stored on the phone itself with room. So at this point, I have enabled the airplane mode. So now I can just go again to the favorites, see the favorites that I have saved. And if when I want to look for another cocktails, it won't let me fetch those because I don't have internet right now. But let's say if I want to search again for the current preloaded margaritas cocktails, I have them all because I fetched that into the app when the app started. So when I had internet, I just fetched that, stored into the server, and now I have it for to see it. So how this app works? So first of all, we need to separate our application in different modules. As we see in the presentation, we have activity and fragment component right here. It's a module. So that module will be inside the UI package. So inside the UI package, I have main fragment, two packages that are the favorite UI, which has the fragment and the adapter because it has a list, a recycler view. Then I have the cocktail details, that is another screen. So in the UI package, it will be only the fragments and activities, nothing more. We are just having right here the UI components, nothing else. So now let's see the main fragment. So this is from where the app startups. So let me just make it a little bigger. So this app has it has dependency injection, view binding, and more things that are implemented into the project that we are not going to talk about that, but instead we're going to talk about the architecture. So the entry point of the application, the first screen that you are seeing right here is the main fragment, the main fragment. So what this does, so the main fragment, when it starts up, it needs to fetch data from the server. So I will not fetch data inside my UI because I just want this fragment to just show me UI. So what I do is first I initialize a view model where I have all my business operations that will go to the repository. Then I define an adapter where I just place in all my items, my list of cocktails, and then in my own view created, what I do is just initializing the recycle view, and then I just fetch the cocktail list. So this is the most important part. As you can see right here, I am using a method. It's not a method because it doesn't have the parentheses on that. So it's a variable. So we're gonna talk about that in the view model. But I am calling a variable in the view model. And I am also observing that variable. When I observe this, I am expecting to return a live data from the view model. And since I am observing this, I'm waiting for that live data to be set up with any data into it. So in the moment that the live data is set with new data, this observe will trigger and it will execute this code inside. And what that code inside do? First, it will show an empty container that is nothing to show into the UI. And then with the results of that live data, if the results are empty, I show an empty container. And if the results are not empty, I will be setting the cocktail list into the adapter. And when I set that cocktail list into the adapter, I will notify the adapter. So this code has the set of the cocktail list into the adapter and then a notified dataset change. This will populate all my recycler view with the data that is coming from the view model. But the data coming from the view model comes from another place. So let's go to the second layer. This was the UI layer that is calling some method or some variables in the view model to fetch data or to bring data to the UI. So now let's go to the second model. The second model is the view model. So the view model will be in the presentation layer. Why it's called presentation layer? So the presentation is used for preparing data for the UI. So the view model will go fetch the data somewhere else. Then it will prepare that data, doing the maps, transformations, or anything like what we need in the UI. And then it will deliver that data into the UI with live data. So let's go to the view model. I hope this can be seen. I am doing it as big as possible, but I hope it's clear. So let's go to the view model. So the view model has a constructor and the constructor has a repository. I'm explicitly injecting into the view model a repository instead of creating an instance right here because I don't want to create an instance each time this view model is instantiated. Instead, I want to provide to the view model an instance of the repository. But instead of just calling the right implementation, the concrete implementation of the repository, I'm calling an interface. So I am doing some abstraction right here to not let the view model know where the code of the repository is implemented. So I depend on an abstraction right here that is the repository interface, and then I have a toast helper and a save state handle. This save state handle is really in handy and is really important because it will survive process death. So when we close, let's say, our app, let's say we have this UI fetch right here, and we minimize this app, and we can go to another app, let's say calendar, and do another operations, and then go back and open another application and so on. After that, if we want to go again to our application, let's say this cocktail app, maybe the system has cleared some process and maybe this process has been killed already. So maybe the process is killed, and when we enter again the application, all the data that the view model has into the live data, it will be lost for that process dead. And we will be facing inconsistencies between the data that the UI is showing, because the UI will save the state, but the view model will not save any state. And since the process has been removed and it's dead, all the live data will be lost, all the information. So it's really important to also use save state handle and get our information from that. So inside the view model, there are no fancy things. The only thing that I have is a variable that calls fetch cocktail list, and it has the current cocktail name that is a mutable live data. I don't want to dig so into the view model. I want to let you understand how the architecture works. But all of these things can be just Google, and you can just find them up and look what they does. But basically right here, we're doing the fetch cocktails from the repository. We all wrapping all this call into a live data scope, and it will be just called when the data inside the mutable live data is changed. So if the value is the same as we are trying to call, let's say I'm trying to call again Margarita right here, I won't be doing the call to the server, since this Margarita name has not changed. So since it not changed, the data being pulled from the server. And then the switch map will deliver to any observers of that live data the results of the emissions right here. So first I will emit a loading state, and then I'm going to the repository and get the cocktail by name. So I just typed Margarita or type gin or anything that I want to search, and it will go to the repository. And for example, if I want to, I think I can put coffee. If you want to search for coffee in the database, when you enter coffee to the search box, it will be here. It's not equal to Margarita. That was the latest value stored right here, so it will trigger the switch map. The switch map will trigger the live data. There is a coroutine scope inside a coroutine scope. This coroutine scope will be canceled when this live data is not active anymore. So this live data KTX extension will grant us that the coroutine will be canceled when the live data is not emitting any value or is not active anymore. So that is a really nice thing about KTX and all the extensions that they provide. So I emit a loading, and then I'm going to the repository, fetch the cocktail by name, and collect in every cocktail in the list and just emit. When I do this emission, all the observers that are observing for this variable, that emit will emit a live data. And since I am observing live data, it will be triggered. So each time something comes from the server, it will be emitted to the UI. And then the UI collects that data and just show it in the recycle view. The view lifecycle owner right here is just a lifecycle scope, and it's bundled to the life cycle scope of this fragment. So when the fragment is destroyed or on pause or any life cycle of the fragment, it will be removing the observers and will be adding new observers instead of placing observers on top of each other and duplicating observers. And with that, we could get any problem of having multiple observers in the same live data. So instead of that, we just pass view lifecycle owner in the fragments, and we can pass this on the activities. But this is really, really important to have to detach observers and attach and create new observers. Sorry, remove and create new observers. So the last part of this is we are going to the repository right here. This is an interface, as I said. So let's go to the implementation of this repository. And since the repository is the default cocktail repository, we can go to the network or we can go to the local data source. The get cocktail by name will receive a cocktail. Then it will offer the cocktails that are inside the cache. If there are none, it will go to the server. It will fetch for those cocktails. It will come from the server with the cocktail details. It will store the cocktails inside the local data source. I mean, with room, we will be storing the data inside our local database, and this is known as the a single source of truth. There is a concept that is called single source of truth. Your data should come from one source. You can't have a call from the server and a call from the local database to fetch the exact same data. You need to concentrate all your calls either from the server or either from your local data source. In this case, I'm going to the server to fetch the latest cocktails or the current cocktail that I'm searching for. and then I'm saving that into the local data source, and then offering to the view model the latest local data stored from the call that I did to the API. So I'm always having my local cache updated with the latest calls to the server. This is all about the repository layer that we have right here in the graph. So what we saw right here is that if we go to the network, we are going to call a remote data source, and then we are going to store all that data inside the model, and then just bring the model to the view model. So that's the data. So the last part is going to go to the data source. For example, this is the network data source. It just fetches data from retrofit. There is nothing more than that. It will just fetch from the API. And then if we go, for example, get cached cocktails, it will just fetch the cocktails inside our database with room. And here we have our local data source, and we can get, for example, where is it? For example, get cached cocktails right here. It will go to the DAO, and it will do a query that selects all the cocktails from the local database. So that's all that we need to know. And let's say if I want to add a new feature right now. So if I want to add a new feature, for example, any operations, I just add a new operation right here with the query, and I just add a new suspend method to work with coroutines, and I just add a new operation right here. After I add this operation in the local data source, I go right here. I just create another method that will use that interface, and then in the repository, I just go to the interface of the repository, create a new method. I have the new feature right here. And since I have the feature in the repository, now I can call that feature from the view model. Let's say repository that new feature, and then that feature will deliver the data to the main activity or main fragment. So we are just touching what we want to change and not all the project. So if we missed right here, if we have any problem right here, it will be just in the local data source or the web network data source. The error will be right here and will not cause any problems or in any of the other package. So working like this is really, really clean. As we can see, we have the domain layer where we store the repository. We have the data layer where we store the local and the network data source, and the core package is just some things that are utils for the application. And then this is all dependency injection that we are not talking about. But the main package are data, domain, and presentation, and UI. This package should be like that. And the communication between those is what we talked before. So let's move to the presentation again, and let's wrap all these concepts up. So to finish this talk, I want to do some recommendations because it's not easy at the first time to dig into architecture. Maybe we are doing all our code into a main activity, or we are just splitting our code as we can, or doing the best. But I know that it's not easy at first to start with clean architecture or doing this kind of architecture in our application. And for that, I have recommendations. First of all, I really recommend the talks for Uncle Bob. We can find in YouTube Robert C. Martin Clean Architecture and Design. This is a really, really nice talk. It's about an hour long, but it's each second is really, really precious. I mean, it's really nice. It has tons of recommendations, how to work with the teams, how to build up our mind about clean architecture and why it important. This talk is really nice, and it's really inspirational. I mean, if we hear at some conferences from Robert C. Martin, we can just know how important is clean architecture. Then there are books about clean architecture, also written by Robert C. Martin, and I had the opportunity to read these books, and I really recommend this book. This clean code book will tell you how to work clean, what are some problems in a so you are going to be set up with a code that has errors, and then you can find you will be challenged to find the errors, and then it will just solve that those errors with clean architecture, and will make your way out your way in sorry into clean architecture. It has tons of examples. It has tons of histories and
Hey,
really nice things.
Gaston. Hello.
Yes.
Hi, Gaston. Sorry there. We're actually running out of time. Is it okay if you can wrap it up already? And if they have any questions, they can just
Yep.
email you or whatnot.
Yes. Yes. No
Yeah.
problem.
Okay.
So I have two more slides, and I finish the presentation.
Okay. All
So
right.
this book is really nice, and the other one is the clean coder. This is more about how to handle professionally in a team, and how to work with good practices,
Yes, two more slides.
and it's really nice book also. So before finishing, there are some links. I will let this presentation